Okay, now you see example 10. We want to find the nearest distance between a point and a line. Okay, so what is the nearest distance between a point and a line? Okay, or the nearest distance between two parallel lines. Okay, let's say I have this. This is a line. Of course, you are given a point. Okay, let's say that I just simply write down the line. Let's say the equation is like this. Let's say it's 1, 2, 3 plus mu, and then let's say negative 1, 0, 3 like that. Okay, so that means here we have one point like that, 1, 2, 3, and then negative 1, 0, 3 is the direction. Remember, this is the point. Okay, so now let's say I have a point A, position vector. Let's say I have a point, another point, let's say 3, negative 2, 0. Okay, so let's say the point is here. Okay, A, the point is 3, negative 2, 0. Okay, so I want to find the nearest distance between the point and the line. That means I must take the perpendicular distance. That means this one must be 90 degrees. That is the nearest. You cannot take this. This is further. Or you cannot take this. This will be further, isn't it? This is the nearest. So this is the nearest distance. That means this one must be 90 degrees. Okay, so how are we going to find that? Okay, so I show you example 10. We look at example 10. Okay, the Cartesian equation of a line L is given as this. Okay, this is Z, typing error. This is Z. The position vector of point A and B are given as this. We have point A, OA, and OB. So we are going to show that P lies on L while A does not. So we want to show that B is on the line, but B no. Okay, A no. So the line can be written like this. XYZ is 3, 2, 2 plus mu. This is the direction 1, negative 1, 2. Okay. So that means we know the line is like this, something like this. I just simply draw a line, and this line passes through the point 3, 2, 2. This is the point, and then the direction is 1, negative 1, 2 like that. Okay. So now I want to know whether this point is on the line or not. 2, 1, negative 2. So I just take this one, I substitute into this, like what I have done just now in example 9. So I just find for the mu, and then I have mu is not consistent. So the value of mu are not consistent, therefore does not lie on the line L. So, and then we are going to test another point, which is B, whether B is on the line or not. So B is 414 given, isn't it? 414. So B is this point. Then I substitute the point, and then I saw mu is consistent. Here I get the value of mu are consistent. That means it's 1. So B is 414. That means it lies on the line. Meaning like that. Just now I said the line is like this. We have one point here. The point is 3, 2, 1. This is the starting point. And then you walk in this direction. 1, negative 1 and 2. Okay, here. So that means you see mu 1 means you just walk 1 hour, then you will reach the point, and this point is B. OB is the vector position is 414 like that. On the point B is 414 like that. Okay, so the point B is 414, and so from here you start from this point. The point is 322, because we get it from here 322. So you just walk for 1 hour in this direction, you will reach this point. That means this point is on the line. Okay, that is how we show. Okay, then second one, hence find the perpendicular distance from A to the line L. Since A, just now we have shown this, A is not on the line, B is on the line. So the starting point just now, starting point here is 3, 2, 2, and then B is on the line. B is here 414, and then A is not on the line. So we are asked to find what is the perpendicular. Let's say A is here. We want to find the perpendicular distance here, D. This is A. Okay, so A, the coordinate is 2, 1, negative 1. Okay, so we are going to show, find the distance. Okay, so I show you here. Here, this is the diagram. I show you. This is the diagram. Okay, this is A, 2, 1, negative 2. And then this is our starting point. Just now I said 3, 2, 2. Our starting point here, 3, 2, 2. We start from here. And you want to find this perpendicular distance. Okay, you want to find this distance. So you want to find this distance. Let's say I call this distance to be D. What am I going to do now? You look at this triangle. This is a right angle triangle, isn't it? So you want to find D. You want to find this distance. You just take D over this length equal to sine theta. So I just use sine theta equal to D over the length of PA, isn't it? The length of PA. Or sine theta is equal to D over magnitude of vector PA. Either one. Okay, so what you have to do now, you must find theta. You can find theta, you just dot this one with this one. I say already, when you want to find angle between two vectors, you just dot. You dot the direction, not the point. You dot this direction with this direction. So you have to find PA. So you have to find PA. The vector PA can be found. Okay. So after that, you just take D multiply with the magnitude of PA. Then you get D. So this is what I'm going to do. Okay. Now what you see, I show you. Okay, the line L is given this as this, the point and the direction. And then that's why you see now I start to find PA. PA is OA minus OP. Okay, so I get this. This is PA. Then now I'm going to find the angle first. Okay, I'm going to find the angle. Okay, here the length PA. Okay, you can find here or later also I find. You want to find the length PA, this will be magnitude. That means it's 1 square plus 1 square plus 3 square. Is it? So the magnitude, the length PA will be square root of 11. That means this length is square root of 11. The length. The length is square root of 11. Now the next thing I'm going to do is I'm going to find theta. So how to find theta, the angle between two vectors? I just dot. I take PA, I dot with this. Then magnitude PA, magnitude this one, cos theta. So I just dot. You know how to dot. This one we have learned already how to dot. So you dot, you get this. Then you find with your calculator. I found it just now is 137.36. That means the angle that we get is this one. Because this is obtuse. That means we get this angle, obtuse. So because I want to find D, I must take the acute angle is 42.24 degree. So I can get this angle is this one. Okay, so now I'm going to find the length of PA. I take the magnitude is square root of 11. This is what I have done just now. Okay, so now you can get the perpendicular distance. Because you look at this triangle, D over square root of 11 is equal to sine 42 degree, opposite over hypotenuse, 24 minutes. So the D is this one. Okay, so you see, I tell you, if let's say you want to find the length of PA, actually you want to find the length of PA is also the same like what we have done is form 4, isn't it? Okay, if you want to find the length of PA, that means it's square root. This is x2 minus x1 square, y2 minus y1 square. This is form 4 because we do 2-dimension problem. Then this one is z2 minus z1 square. It's the same one. So you see, okay, you look back at our point. P is the point 3, 2, 2. Is it? And then A is the point 2, 1, negative 1. So you just minus 3 minus 2. 3 minus 2 square. Then 2 minus 1 square. Then Z is 2 minus 1 square plus. So you get square root 1 square plus 1 square plus 3 square. So it's square root of 11. It's the same one. So this is actually the same, but you can do it like this, of course, or you just do it like this. You find the vector PA, then from the vector PA you find the magnitude. You find the magnitude. That is the distance. Okay, either way. So that is how you find the distance. And then from this triangle, you know this distance is square root of 11. So d over square root of 11 is sine of this angle. But here we found the angle is this obtuse, so you must take this. So sine of this angle is d over square root. So you find the d. Okay? That is how you find. Okay, then the last part. If f is the foot of the perpendicular from A to L, the line L, find the coordinate f and the distance of BF. So he said f is the foot of the perpendicular. This is perpendicular. So you are asked to find what is the coordinate here. Okay, so because f lies on this line, this is a starting point. So we assume now we want to find the point f. So how to find the point f? So here we assume, start from this point. If I want to reach this point f, I have to take how many hours? Let's say I need t hours. So start from this point. So I have to move along this direction for t hours. Then I will reach f. Meaning like that. I have to move t hours or t kilometer. Then I can reach f. So that is, so OF will be 3 plus t, 2 minus t, 2 plus 2t. So this is the point. 3 plus t, 2 minus t over 2 plus 2t. That is the point. Okay, then after that I find what is the vector FA. Okay, this is FA. FA is OA minus OF. Why I find the vector? Because afterward this one and this one perpendicular. So I'm going to take this one dot with this one. I will get 0, then I can get the t. This is what I'm going to do. So I have point A, OA, I have OF. OF means I just assume from this point to F I need t hours or t steps. So I'm going to find t. If I know what is t, then I can know f already. Okay, so OA minus OF, I find FA. So I minus this one minus this one minus this one minus this, I get this. Then I get the FA. This FA, the vector is negative 1 minus t, the FA, and then t minus 1, and then negative 3 minus 2t, and then I dot these two. Because of perpendicular, I dot them, I should get 0. So you see, since FA is perpendicular to L, so when you dot them, you will get 0. So when I dot, then I simplify, I get t equal to negative 1. That means from this point, I want to get into F. Actually, the point 3, 2, 2 is here. Then this point is here. That means A is here. That means the F is here. That means I have to walk this step. I have to walk this direction. That because I get negative 1. That means I have to walk. That means F is here. So since F is negative 1, so I substitute back here. T is negative 1, I put it back here, then I can get OF. Or I substitute here, say. T is negative 1, so I get 2, 3, negative 1, this one will be 0. Is it? So I substitute, then I get OF is 2, 3, 0. That means I know F, the coordinate of F is 2, 3, 0. That is what I know. Okay, I know the F, the coordinate is 2, 3, 0. The position vector is 2, 3, 0 like this. Okay? Okay, then this is how I find the coordinate of F. Okay, then after that, after you find the coordinate of F and find the distance of BF. So you want to find the distance of BF. Okay, you see there are two ways. You see, F is 230. You see, you know the F is 230. You see, I show you here. We know already F is 230. F is 230. And then what is the B? B is 414. So you want to find the distance of B to F. The distance. Okay, either we use vector like this, magnitude, or you can use this way. That is x2 minus x1 square, y2 minus y1 square plus z2 2 minus z1 square. You can use either one. So now I show you this, after I show you this. So here, minus 2 minus 4 square, 3 minus 1 square, and then 0 minus 4 square. So you get square root. This is 4, 4, 16. So you get 24 of, this is 4 times 6. So it's 2 square root 6 unit. That is the distance. Okay. Now if you see, if I show you using this way, then you have to find, okay, you see here, okay, you have OF is this one, OB is this one. That means if you want to use the magnitude way, vector way, magnitude of vector, you must find BF. So how to find BF? OF minus OB. Actually, it's the same one. You see, then very negative, all this. And then the distance of B to F is the magnitude of BF. So you find the magnitude, same. You get the same answer. So you see, it's exactly the same. Okay, that's all. Then you can try. Okay, I just tell you something here, 62. So I just take the opportunity here. I straight away tell you how to do 62. Okay, 62. Here you are asked to find the nearest distance between the two parallel lines. Now you know the lines are parallel. The two lines are parallel. So how are we going to find the distance, the nearest distance between them? So you see, I just show you, then you have to do it yourself. Okay, for A, 62A, you have x, y, z. This is 5, negative 3, 1 plus s. Then this is 1, negative 4, 8. That means, and then for line number 2, x, y, z, this is 2, negative 4, negative 1. Okay, plus t, 1, negative 4, 8. So correct, 5, negative 3, 1, and so on is correct. Okay, so now I'm going to find these two lines are parallel. You see or not? They are parallel. They are parallel. So I want to find the nearest distance between them. So what I do here, I know the first line, line number 1. This is line number 1. This is line number 2. Line number 1, I know it has one point here, 5, negative 3, 1. Is it? And then line number 2, L2. This is L2. Here it has one point here, 2, negative 4, negative 1. So I'm going to find the nearest distance between them. So you can take this distance. You want to find this distance D. Okay. So what we do here, you can find this. Same what? Same like. Then here you can find the distance, and you can find this angle theta. Then after that you can find the length D, correct or not? Using the method that we have learned just now, this one, like exactly like this. Okay, just now I show you example 10, exactly like this. So you have to do this. You have one point here, you have one point here, so you can find the nearest distance. Okay, you find the angle theta like here, what you have done here, exactly the same problem. Okay, right? Okay,